September 1944. The air was thick with the acrid smell of burnt cordite, the damp earth churned into a greasy mud by countless tank tracks, and the distant rumble of artillery was a constant, unsettling heartbeat. A Sherman tank, bearing the distinctive white eagle insignia of the 1st Polish Armoured Division, lay crippled and motionless on a narrow, muddy track leading directly into the inferno of the Falaise Gap. Its engine, a massive Continental R975 radial, had finally seized, a victim of the relentless grind of continuous combat, the unforgiving demands of the battlefield, and the sheer impossibility of proper maintenance. Inside the stifling turret, the crew, utterly exhausted and consumed by a bitter frustration, knew their fight was over, at least for this particular war machine. They were just one of countless crews across the Allied front, facing the same grim, demoralizing reality. Tank engines, the very heart of their war machine, were failing at an alarming rate, demanding constant, resource-intensive oil changes that often simply couldn't be met. This logistical nightmare, a silent, insidious enemy, threatened to stall the entire Allied advance as effectively as any German counterattack. But in the midst of this mechanical despair, a quiet, unassuming Polish mechanic harbored a radical, almost insane idea. A concept so audacious it promised to defy the very limits of wartime engineering and perhaps, just perhaps, turn the tide of mechanical attrition. To truly grasp the audacity of this seemingly impossible feat, and how such a concept could even be conceived, we must first journey back to the brutal, unforgiving realities of armored warfare in the Second World War. Tanks were not merely vehicles. They were the spearhead of modern armies, mobile fortresses designed to break enemy lines and exploit breakthroughs, but their immense power and strategic importance came at an incredibly steep price. Their engines, whether the gasoline-powered radials common in American Shermans or the diesel units found in British tanks, were pushed to their absolute breaking limits. They operated in environments choked with fine dust that infiltrated every seal, thick mud that caked every moving part, and the constant threat of shrapnel and small arms fire. They endured extreme temperature fluctuations, from freezing nights to scorching days, and the incessant vibrations of cross-country movement. Each hour of combat was not just an hour of fighting, it was an hour of accelerated wear and tear, equivalent to hundreds of hours of normal operation. Lubricating oil, the very lifeblood of these complex precision-engineered machines, degraded rapidly under such brutal conditions. It became contaminated with abrasive metallic particles flaking off bearings and gears, carbon deposits from incomplete combustion, and fuel dilution from imperfect seals, quickly losing its critical viscosity and protective properties. Standard operating procedures, meticulously outlined in thick manuals, called for incredibly frequent oil changes, often after just a few dozen hours of operation. This was a logistical burden of staggering proportions, stretching already strained supply lines to their absolute breaking point. For the Polish 1st Armoured Division, fighting thousands of miles from their ravaged homeland, relying entirely on the often delayed and overstretched Allied supply chains, this challenge was particularly acute and demoralizing. Every gallon of fresh oil was a precious commodity. Every hour spent on maintenance was an hour not spent advancing towards their ultimate goal, a free Poland. The specific situation facing Polish tank crews in the summer and autumn of 1944 was nothing short of dire. Following the monumental D-Day landings in June, the Allied armies had begun their relentless push eastward across France, but the advance was anything but smooth or swift. The infamous hedgerows of Normandy, a labyrinthine network of ancient earthen banks and dense foliage, turned every field into a deadly ambush. German resistance, though often outmatched, was fierce and fanatical, characterized by desperate counterattacks and cunning defensive tactics. The constant threat of enemy action meant that tanks were in continuous, high-stress operation, often for days on end, without adequate rest for their crews, or, crucially, proper maintenance facilities for their machines. The Sherman tanks, while generally robust and reliable, were not immune to these immense pressures. Their engines, originally designed for a different kind of war, struggled immensely with the prolonged, high-intensity combat of the Western Front. Mechanics, often young men with grease-stained faces and weary eyes, worked around the clock, frequently under the terrifying whistle of incoming shells, desperately trying to keep the tanks running. They scavenged parts from wrecked vehicles, improvised repairs with whatever materials were at hand, and pushed their machines beyond their intended design limits. But the fundamental, intractable problem of oil degradation remained. Without a steady supply of fresh, clean oil, engines seized, tanks became immobile hulks, and vital combat power was lost at the most critical junctures. The battlefield was not just littered with tanks destroyed by enemy fire, but also with those rendered inert by mechanical failure, awaiting precious supplies and the skilled hands of mechanics, resources that were always in short supply. The desperate need for a radical solution was not just a tactical inconvenience. It was an existential threat to the momentum of the entire campaign, a silent killer of armored divisions. It was against this backdrop of relentless mechanical attrition and profound logistical desperation that the figure of Janusz Karski emerged. He was a man of quiet demeanor, often lost in thought, but possessed a prodigious, almost savant-like mechanical intellect. Karski served as a senior mechanic within the ranks of the 1st Polish Armored Division, a unit renowned for its fighting spirit and resourcefulness. Born in a small, bustling industrial town near Łódź in pre-war Poland, Karski had spent his entire youth immersed in the intricate, fascinating workings of machinery. He possessed an almost intuitive understanding of engines, a gift honed by countless hours spent tinkering with everything from the simplest agricultural tractors to the most complex early automobiles. His hands, though calloused and scarred from years of hard work, moved with a surgeon's precise, deliberate grace, and his eyes, often thoughtful and distant, missed no minute detail, no subtle anomaly in a machine's operation. He had joined the Polish army before the outbreak of war, serving as an instructor in automotive mechanics, and had seen firsthand the devastating, rapid impact of modern warfare on even the most robust equipment during the brutal September 1939 campaign. His subsequent escape from occupied Poland, a harrowing, perilous journey through the mountains of Romania and across the chaos of a collapsing France, had only deepened his resolve and sharpened his focus on finding practical, innovative solutions to what often appeared to be insurmountable problems. Janusz Karski's early life was a profound testament to the power of innate curiosity, relentless self-education, and an unyielding dedication to understanding the world around him. Growing up in the industrial heartland of Poland, the rhythmic hum and clatter of machinery was not just background noise, it was the very soundtrack to his childhood, a symphony of gears, pistons, and steam. His father, a highly respected and skilled machinist in a local factory, instilled in young Janusz a deep, almost reverent respect for precision, the elegant logic of mechanical systems, and the satisfaction of a job done perfectly. While other boys his age were engrossed in games of football or chasing adventures in the nearby forests, Janusz could invariably be found in his father's workshop, a sanctuary filled with the scent of oil and metal. There, he would meticulously dissect old, discarded engines, patiently cleaning every component, studying the intricate dance of gears, and reassembling complex mechanisms with an almost preternatural understanding that belied his tender years. He devoured every technical manual, every engineering blueprint he could lay his hands on, his brilliant mind absorbing the fundamental principles of combustion, lubrication, and material science with astonishing speed. He didn't just learn how things worked. He developed an innate understanding of why they worked, and crucially, why they sometimes failed, a distinction that would prove invaluable later in life. This foundational knowledge, combined with a fiercely pragmatic hands-on approach, set him apart from his peers. By the time he joined the Polish army in the late 1930s, he was already a master mechanic, his theoretical knowledge matched only by his extensive practical experience. His instructors quickly recognized his exceptional talent, often finding him politely correcting their own diagrams or suggesting more efficient, elegant repair methods. His experiences during the lightning-fast German invasion of Poland in September 1939 were not just formative, they were deeply traumatic and profoundly influential. He witnessed the rapid, devastating destruction of Polish armored units, not solely from overwhelming enemy fire, but equally from the relentless onslaught of mechanical breakdowns exacerbated by a critical lack of spare parts and proper field maintenance. He saw tanks, perfectly capable of fighting, rendered utterly useless by something as seemingly minor as a fouled carburetor, a worn-out bearing, or a contaminated fuel line. This first-hand exposure to the brutal, unforgiving realities of wartime logistics, where a single broken part could mean the difference between holding a line and a catastrophic retreat, ignited a powerful spark within him. After his harrowing escape from Poland and his eventual integration into the Polish forces forming in the West, first under French command, then with British and American equipment, Karski continued to serve as a mechanic, always observing, always learning. He consistently pushed the boundaries of conventional repair, often improvising ingenious solutions that initially baffled his peers, but invariably worked with remarkable effectiveness. He once famously kept a crippled Matilda tank running for weeks in the harsh North African desert by fabricating a critical engine part from salvaged truck components, a feat that earned him both a rare commendation and the admiring nickname, the Alchemist, among his fellow mechanics. He saw the immense waste, the inherent inefficiency, and the sheer logistical impossibility of maintaining a modern armored force with traditional peacetime methods under the relentless pressure of combat conditions. The constant, insatiable demand for fresh oil, the endless, resource-draining cycle of draining, replacing, and disposing of contaminated lubricant struck him as fundamentally unsustainable and utterly illogical. The intellectual journey from conventional thinking to his crazy idea wasn't a sudden, blinding flash of genius, but rather a slow, persistent burn of frustration, coupled with meticulous observation and relentless experimentation. He spent countless hours poring over intricate engine schematics, studying the complex chemical properties of lubricating oil, and analyzing the precise failure modes of tank engines. He noticed a crucial detail. Much of the spent oil wasn't truly spent in terms of its fundamental lubricating base. Instead, it was merely contaminated. The base oil, the fundamental component responsible for reducing friction and dissipating heat, was often still viable, its molecular structure largely intact. The real problem lay in the accumulated impurities, metallic particles, carbon soot, water, and fuel dilution. He began to experiment in secret, using rudimentary equipment scavenged from abandoned workshops, wrecked vehicles, and even local farms. He filtered oil through layers of tightly woven canvas, fine sand, and even charcoal, boiled it over makeshift fires to evaporate water, and tried crude chemical treatments using whatever acids or bases he could safely acquire. Most of his early attempts were, predictably, failures, producing oil that was barely better than what he started with, or worse, actively harmful to an engine. But with each failure, he learned something new, refining his understanding of the contaminants and the methods required to remove them. He realized that the solution wasn't just simple filtration, it was a comprehensive, multi-stage process of purification and revitalization. The moment of true conceptual crystallization came during a particularly brutal stretch of fighting in Italy, when his unit was completely cut off from fresh supplies for an extended period. He watched, helpless, as tank after tank ground to a halt, their powerful engines choked with sludgy, degraded oil. It was then that the full, audacious scope of his crazy idea solidified in his mind. What if they could not just filter the oil, but truly recondition it, making it almost as good as new, right there on the battlefield, under combat conditions? The dilemma facing Janusz Karski was immense, a clash between desperate necessity and deeply entrenched military doctrine. The prevailing wisdom in military engineering, meticulously codified in regulations and manuals, dictated strict maintenance schedules and the exclusive use of fresh, factory-sealed lubricants. Any deviation from these established norms was seen as an unacceptable risk, potentially leading to catastrophic engine failure, the loss of vital equipment, and, most critically, the endangerment of tank crews. Karski's radical idea to extensively recondition used engine oil in the field for prolonged reuse flew directly in the face of every established protocol, every safety guideline, and every logistical assumption. When he first tentatively proposed his concept to his British commanding officer, Major Thompson, it was met with polite but firm skepticism, bordering on incredulity. "Karski," Thompson had said, his tone a mixture of respect for the mechanic's past ingenuity and a deep-seated adherence to procedure, "we appreciate your innovative spirit, but engine oil is a precise chemical compound. You can't just clean it like dirty water. It loses its molecular integrity under heat and stress. We simply cannot risk our precious tanks and the lives of our men on such an unproven, frankly crazy notion." The logistical officers, equally bound by regulations and concerned with resource allocation, were even more dismissive, arguing that the specialized equipment and expertise required for such a complex process would be far more cumbersome and resource-intensive than simply supplying new oil, even if it meant stretching supply lines. Karski understood their concerns. He knew the risks involved. But he also knew with an unwavering certainty that the current system was failing, costing lives, precious equipment, and most importantly, the vital momentum of the Allied advance. He was utterly convinced that his unconventional approach, though seemingly reckless, was the only viable way forward in the face of such overwhelming logistical challenges. Despite the formidable wall of official resistance and ingrained skepticism, Karski was not deterred. He understood that words alone would not convince. He needed irrefutable proof, a tangible demonstration of his concept's viability. His moment of decision, the critical juncture where theory met desperate reality, came during a brief, tense lull in fighting near Caen, France, in the sweltering summer of 1944. A squadron of Shermans, part of the Polish division, had been particularly hard hit by engine failures, with several tanks sidelined due to the critical lack of fresh lubricating oil. Desperate, and with his back against the wall, the squadron commander, a pragmatic and battle-hardened Polish captain named Marek Zielinski, approached Karski. "Janusz," he said, his voice low and weary, "I've heard whispers of your alchemist methods, your strange experiments. My tanks are dying, Janusz. We're losing combat effectiveness by the hour. If you have a crazy idea that might save them, I'm willing to listen, even if it means risking my career and facing the wrath of headquarters." Karski, recognizing this as his one fleeting opportunity, seized it with quiet determination. He outlined his audacious plan. He would take one of the crippled Shermans, drain its degraded, sludgy oil, and put it through his improvised multi-stage reconditioning process. If it worked, if the engine roared back to life and ran reliably, then they would have a solution. If it failed, if the engine seized again, they would be no worse off than they already were, and his crazy idea would be definitively put to rest. Captain Zielinski, against the explicit advice of his British liaison officer and with a heavy heart, gave Karski permission to proceed, assigning him a single battered Sherman and a small team of initially skeptical mechanics. The stakes were incredibly high. If Karski succeeded, he could revolutionize tank maintenance and provide a critical advantage. If he failed, it would be a costly waste of precious time and resources, and his crazy idea would be forever dismissed as a dangerous pipe dream, potentially ending his career and any hope of similar innovations. Karski's crazy idea was, at its core, deceptively simple in principle, but incredibly complex and labor-intensive in its execution, especially under battlefield conditions. He had devised a multi-stage, field-improvised oil reconditioning system, a testament to his ingenuity and resourcefulness. The process began with the careful draining of the used, heavily contaminated oil from the tank's engine. This murky black liquid, thick with carbon and metallic particles, was then transferred to a large modified fuel drum, which served as the primary heating vessel. This drum was placed over a slow, carefully controlled fire, often fueled by scavenged wood or even discarded crates. This heating process, meticulously monitored by Karski to avoid dangerous overheating, served a crucial purpose. It helped to evaporate any water contamination and lighter fuel contaminants that had diluted the oil's lubricating properties. Next, the heated oil was passed through a series of progressively finer filters. These were not standard factory-made filters. Karski had ingeniously improvised them, using layers of tightly packed wool salvaged from old blankets, fine sand collected from riverbeds, and even activated charcoal made from burnt wood, all encased within salvaged metal mesh and perforated tin cans. Each stage removed larger and then progressively smaller particulate matter. The most ingenious and perhaps most audacious part of his system was the final stage, a rudimentary electrostatic precipitator. This device, painstakingly built from an old radio transformer scavenged from a wrecked vehicle, scrap metal and insulated wires, was designed to create an electrostatic field. Karski believed correctly that this field could attract and effectively remove microscopic carbon particles and minute metallic debris that conventional mechanical filtration simply couldn't capture. The entire process was agonizingly slow, incredibly labor-intensive, and demanded constant, unwavering vigilance from Karski and his small team. His mechanics, initially deeply skeptical and muttering about black magic, watched in growing fascination as the murky, almost opaque black oil slowly, almost miraculously, transformed. It emerged from the final stage as a clearer, amber-colored liquid, visibly cleaner and with a renewed translucence. It wasn't perfectly pristine, certainly not like fresh oil from a sealed barrel, but it was remarkably improved. Karski would often dip his fingers into the reconditioned oil, rubbing it between his thumb and forefinger, swearing he could feel the difference in its viscosity and slipperiness. Finally, with a mixture of hope and trepidation, they refilled the Sherman's engine with this reconditioned oil, a mixture that had been deemed utterly unusable just hours before. The moment of truth arrived when Captain Zielinski, his face etched with anxiety, gave the order to start the engine. The massive Continental R975 coughed, sputtered for a tense few seconds, and then, with a glorious roar, burst to life, settling into a steady, powerful, and reassuring rhythm. It ran smoothly, without the telltale knocking, excessive smoke, or labored sound that indicated degraded lubrication. The engine, once thought dead and destined for a lengthy, resource-draining overhaul, was alive again, a testament to one man's unwavering belief. The immediate result was nothing short of miraculous, a profound vindication of Karski's unconventional thinking. The Sherman tank, which had been slated for recovery, a lengthy journey to a rear-echelon workshop, and a time-consuming overhaul, was now back in operational status within a single day. Its powerful engine, once silent and lifeless, was now purring with a renewed vigor that astonished even the most seasoned and cynical mechanics. Captain Zielinski, initially cautious and prepared for disappointment, ordered the tank to be put through a rigorous series of field tests. These included extended road marches over rough terrain, simulated combat maneuvers involving rapid acceleration and deceleration, and prolonged periods of idling under observation. The engine performed flawlessly, maintaining optimal oil pressure and temperature throughout the demanding tests. The reconditioned oil, against all expectations and every established engineering principle, held up remarkably well, demonstrating a surprising resilience under the intense stresses of operation. The deep-seated skepticism that had initially surrounded Karski's crazy idea evaporated almost instantly, replaced by a stunned realization of its profound potential and immediate practical value. The news, like wildfire, spread rapidly through the ranks of the 1st Polish Armored Division. A quiet mechanic had found a way to make used oil viable again, potentially solving one of the most crippling logistical problems of modern tank warfare. The morale boost was palpable, a sense of renewed hope in the face of relentless attrition. The success of Janusz Karski's ingenious oil reconditioning system quickly reverberated far beyond the confines of that single, desperate experiment. What began as an audacious gamble on a single tank soon became standard, indispensable practice for the division's field maintenance units. Karski, no longer merely the alchemist, but now revered as the engineer by his grateful comrades, meticulously trained other mechanics in his innovative methods. He refined the process, streamlining steps, and even designing more portable, robust versions of his reconditioning apparatus, making it easier to deploy closer to the front lines. The impact was immediate, widespread, and profoundly transformative. Tanks that would have been sidelined for days or even weeks, awaiting the arrival of critically scarce fresh oil supplies, were now back in action within mere hours, their engines revitalized. The operational readiness of the Polish armored units soared dramatically, giving them a critical, often decisive edge during the intense, grinding fighting in the Falaise Gap and the subsequent rapid push through Belgium and into the heart of Germany. Commanders noted a significant, measurable reduction in engine-related breakdowns, allowing their tanks to maintain relentless momentum and exploit breakthroughs with unprecedented speed and efficiency. While the Allied High Command initially viewed Karski's unconventional methods with a degree of caution, preferring their established, albeit often failing, protocols, the undeniable, irrefutable results and the desperate, pressing need for practical solutions eventually led to the quiet, unofficial adoption of similar field reconditioning techniques across other Allied armored formations. This often occurred without direct attribution to the Polish mechanic who had pioneered it, a common fate for many wartime innovations. Karski's ingenuity, born of sheer necessity, a deep understanding of mechanics, and an unwavering refusal to accept limitations, had fundamentally altered the logistical landscape of armored warfare, proving that resourcefulness could overcome even the most daunting material shortages. The historical impact of Karski's innovation, though often tragically overlooked or relegated to footnotes in official histories, was undeniably significant. By dramatically extending the operational life of engine oil and drastically reducing the insatiable demand for fresh supplies, His system directly contributed to the sustained mobility and combat effectiveness of the Polish armored units. This was particularly crucial for the 1st Polish Armored Division, which played a pivotal, heroic role in closing the Falaise Gap, an engagement that proved to be a decisive turning point, trapping and utterly destroying a large portion of the German 7th Army. Their enhanced ability to maintain a high operational tempo, largely due to the significantly reduced engine maintenance downtime, allowed them to press the attack relentlessly, exploiting every tactical advantage. Karski's crazy idea served as a powerful living demonstration that ingenuity, unconventional thinking, and sheer determination could overcome seemingly insurmountable logistical challenges, proving unequivocally that the human element, the creative, problem-solving mind, even in the technical realm, was as vital and potent as any weapon or strategic plan. It was a profound testament to the Polish spirit of resilience, resourcefulness, and an unyielding will to fight for freedom. An army without a homeland finding innovative ways to contribute decisively to the liberation of Europe. The practical lessons learned from Karski's work, particularly regarding advanced filtration and on-site fluid management, subtly influenced post-war military logistics and industrial practices, highlighting the enduring importance of field-level resourcefulness and the continuous pursuit of technological efficiency. His story became a quiet legend among the mechanics, a symbol of what could be achieved when necessity truly became the mother of invention. After the war, the world that Janusz Karski had fought so valiantly to liberate had little room for his wartime ingenuity, or for many Polish heroes like him. With Poland falling under the oppressive shadow of Soviet influence and a new communist regime, his invaluable contributions to the Western Allies were not celebrated. Indeed, they were largely ignored or actively suppressed by the new authorities. His wartime service with the Western forces, particularly his association with a division that fought alongside the British and Americans, made him a suspicious figure, viewed with distrust by the new political order. He returned to his hometown, hoping to apply his extraordinary mechanical genius to the monumental task of rebuilding his shattered country. However, the political climate was unforgiving. Despite his skills, he found work as a humble mechanic in a state-owned factory, his crazy idea for oil reconditioning, a wartime triumph, relegated to a quiet, almost forgotten memory. He never sought fame, recognition, or personal glory, content in the profound knowledge that his work had genuinely saved lives, kept vital equipment running, and played a small but significant part in winning the war. He lived a quiet, unassuming life, always tinkering, always observing, his brilliant mind still sharp and curious, until his peaceful passing in the late 1970s. His story, like those of countless Polish veterans who fought for a free Poland only to find it under a new form of occupation, remained largely untold for decades, a poignant testament to the complex, often tragic, and frequently unjust aftermath of the global conflict. It was only much later, with the fall of communism, that the true scope of such individual acts of heroism and ingenuity began to emerge from the shadows of history. The story of Janusz Karski is more than just a tale of mechanical ingenuity. It is a profound and moving reflection on the unsung heroes of war, the quiet innovators whose contributions, though often overlooked, are absolutely vital. It reminds us with stark clarity that victory is often forged not solely in grand, sweeping battles and brilliant strategic maneuvers, but equally in the quiet, persistent, and often anonymous efforts of individuals who possess the courage to think differently, to challenge the status quo, and to solve seemingly intractable problems. Karski's crazy idea was born from a deep, empathetic understanding of a critical life-or-death problem and an unwavering, almost stubborn determination to solve it, even when faced with overwhelming skepticism, institutional inertia, and severely limited resources. His contribution, though not always recognized in the grand narratives of history, played a truly vital role in keeping the tanks of the 1st Polish Armored Division fighting, ensuring that their immense courage, their profound sacrifices, and their unwavering spirit were not in vain. It stands as a powerful, enduring testament to the indomitable spirit of human innovation, proving unequivocally that even in the darkest, most desperate hours of conflict, a single, unconventional mind, fueled by ingenuity and purpose, can find a way to overcome seemingly impossible odds, making a lasting impact that echoes through the generations and shapes the course of history.